For decades, we have treated software exactly like the municipal electrical grid. It is present everywhere, it keeps our modern lives running, and it is largely invisible to the people who rely on it. Building something like a complex database meant gathering a team of specialized engineers, spending months on architectural planning, and iterating for years. It required a massive budget that kept the exercise locked firmly inside corporations or well-funded institutions. That economic reality baked a clear assumption into our relationship with technology. Software arrived in a shrink-wrapped box, or through a browser, or as a monthly subscription. You used it, you certainly did not build it. This created a hard, permanent dividing line separating the very small group of specialists who construct our digital world from the billions of us who merely inhabit it. Recently, an AI company called Cursor ran an experiment that shatters that historical model. They instructed a swarm of AI agents to rebuild SQLite from scratch. To understand the weight of that task, SQLite is not a simple weekend coding project. It is one of the most ubiquitous, thoroughly battle-tested databases on the planet, running quietly inside almost every smartphone, computer, and web browser you own. Traditional databases take years and millions of dollars. Cursor's agents produced a working Rust implementation in exactly 4 hours. Total cost, $1,339. They achieved this with a severed internet connection and zero access to the source code. Their only input was this, an 835-page technical manual, a document written in human prose describing how SQLite behaves, how it handles edge cases, and what it guarantees. How does an AI transition from reading a static text document to outputting a perfectly functioning complex system architecture on the other end? This visualization shows a process called forward engineering. Instead of starting with a finished product and taking it apart to see how it works, the agents were interpreting a written description of the system, using the text to invent and assemble the necessary components completely from scratch. The initial assumption is that if you deploy hundreds of highly capable, highly intelligent AI agents simultaneously, they will quickly code their way to a finished database. Cursor's first attempt proved otherwise. They let their most advanced, expensive models handle both the planning and the execution simultaneously, and the result was catastrophic. Agents completely unaware of each other began overwriting shared files without communicating. In one instance, the swarm implemented 3 entirely separate, redundant SQL parsing libraries inside the exact same codebase. Look at the resulting data from that unmanaged run. The total price tag ballooned to over $10,000, and the merge conflicts spiked aggressively past $70,000. Individual files accumulated thousands of competing, contradictory edits. Raw AI capability does not solve complex architectural problems. High intelligence, when completely unmanaged, merely generates organizational noise faster than the system can resolve it. To solve the failure, Cursor didn't inject more intelligence into the swarm. They implemented a strict corporate org chart. This flowchart maps their successful run. At the top, Planner Blanels made high-level architectural decisions. Coding was delegated to a second layer of cheaper worker models, executing specific isolated tasks. Mediator agents intercepted and resolved disputes between workers before conflicts reached the final codebase. They even built an institutional memory system called the Field Guide, a shared folder where agents left detailed written notes for future agents to maintain continuity across the project timeline. Once the agents were managed, the noise vanished. Merge conflicts dropped from 70,000 to fewer than 1,000, and the swarm accurately constructed the database for the target cost of $1,300. An army of super-intelligent agents could only successfully build complex software by adopting the exact project management structures, hierarchies, and communication protocols utilized by human corporations. The Cursor experiment points to a distinct expansion in how we use AI. Early assistance helped engineers complete a few lines of code. Now the unit of assistance has expanded to swallow the entire project specification. This scale illustrates the new reality of engineering. The primary bottleneck has shifted away from the physical act of writing the code, moving directly to the challenge of precisely and completely describing what needs to be built. If AI swarms can handle the heavy lifting of translation, the upstream work takes center stage. The technical writers, the product managers, and the system architects, the people who create the documentation, become the primary drivers of software creation. Which brings us back to the historical assumption of the electrical grid. If a static text document can manifest a flawlessly functioning software architecture, then software is no longer a rigid, permanent structure. Software behaves more like a recipe. It is something that can be independently reproduced, adapted, and baked from scratch by anyone holding the instructions. And when reconstructing a battle-tested system costs exactly $1,339, the economic barrier to entry collapses. The era of simply using software, with no relationship to its construction, is coming to an end. We are looking at a reality where anyone with a well-written manual and an organized swarm of agents will look at the tools they use every day and ask, could I build this myself?